I'm here today to demonstrate our partial quotient method. This is a method of dividing that is unique to everyday math. First, we are going to divide 127 by 8. And you set up your partial quotient problem like a traditional division problem, except you draw a line to the right side of your problem. First, we want to think in numbers that are familiar to us and brain friendly. That could be base 10, and we're going to start with that. And I'm going to ask myself, do I have 10 eighths in 127? And the answer is yes. Yes, 8 times 10 is 80. So I'm going to ask myself now, do I have 20 eighths in 127? And the answer to that is no, because that's 160. So I'm going to pull out 10 eighths. So I'm going to write 10 to the right side of my line. And then I'm going to think 8 times 10 equals 80. So I'm going to subtract 80 from 127. And that gives me the difference of 47. Well, now I have a smaller number to work with, and I can think how many eighths are in 47. This appeals to your math knowledge. I know that 8 times 5 is 40. I know 8 times 6 is 48, which is too big. So I'm going to take out 5 more eighths. And I'm going to think 8 times 5 equals 40. I'm going to write underneath the 47 and subtract, which gives me a difference of 7. Now, my difference of 7 is less than my divisor, so there's no more that I can pull out. But I'm not done with my problem. My next step is to add the amounts of eighths that I pulled out of my original 127, which is 10 plus 5 is 15. And then I have this remainder of 7, so I would mark it as 15 remainder 7. And then I would take this answer and write it on top of my multiplication problem where your answer would go. That is the one example of partial quotient. Let's do a second. Another example that we can do is, let's say we have 876 divided by 12. So I set up my problem the same way. I write my division problem, then draw a straight line to the right of my problem. And now I think, do I have 10 12s? Yes, because 12 times 10 is 120. Do I have 20 12s? Well, 12 times 2, 24, add a 0, so that's 240. Do I have 30 12s? Yes, that would be 360. 40 12s? Yes, 480. Do I have 50 12s? That would be 600. Do I have 7 12s? Yes, because that would be 840. So I'm going to pull out 70 12s. Now I'm going to use my extended math facts, and I'm going to say 12 times 7 is 84, and then add my 0 from the 70 to subtract 840 from 876, which gives me a difference of 36. Now, I have to figure out how many 12s remain in 36. Well, I know that 12 times 3 is 36, so I'm going to pull 3 out and multiply 12 times 3 to get 36. Subtract, I get a difference of 0, so I have nothing left to take 12 out of. So my last step is to add the numbers I pulled out, which gives us a total of 73. And then I would take my number and write it on the top of where my division problem goes. Let's do one more example of partial quotients. And this time, let's do 496 divided by 7. And I set up my problem and end it by drawing a vertical line to the right. And now I ask myself, do I have 10 sevens? Yes, that would be 70. And I know that 7 goes into 49 7 times, so I have to at least have 77. So I'm going to write 70 off to the side, and use my extended math facts. 7 times 7 is 49. Add my 0 from my 70, subtract my difference, which gives me a difference of 6. Well, 6 is less than our divisor of 7, so I don't have anything left to pull out. And I don't have anything to add because I did it all in one step. So my answer would be 70 R6, and then that number would be written on top. The benefit of partial quotient is you don't have to have the exact number of steps. Use the math facts that you know. If you didn't realize that there were 77s and 496, you could do it a different way and still reach the correct answer. And I'll demonstrate in dreams. So say that I wanted to pull out 37. I know that 7 times 3 is 21. Add my 0. So that brings me to 210. And I subtract to get my difference. And I have a difference of 286. Oh, 28. That popped out to me as a fact. Multiple of 7. And I know that 7 times 4 is 28. But it's in the hundreds, so I'm going to take out 40 this time. So 7 times 4 is 28. Add my 0 from my 40. And I subtract. Now I get the difference of 6. And my last step would be to add what the numbers I've pulled out. You get 70. Remainder 6. Take that number, write it above, get 70 remainder 6. So with partial quotients, there are an infinite amount of ways to get to the same answer, but use the math facts that you know.